All right, AP, here comes sample exercise 3.31, determining the number of moles of atoms. Aluminum, Al, is a metal with a high strength to mass ratio and a high resistance to corrosion. Thus, it is often used for structural purposes. Compute both the number of moles of atoms and the number of atoms in a 10.0 gram sample of aluminum. Go ahead and press pause now, because here comes the solution. The mass of 1 mole, meaning 6.022 times 10 to the 23rd atoms of aluminum, is 26.98 grams. You got this from the periodic table. The sample we are considering has a mass of 10.0 grams. Since the mass is less than 26.98 grams, this sample contains less than 1 mole of aluminum atoms. Knowing that, we can calculate the number of moles of aluminum atoms in 10.0 grams. We start with the 10.0 grams of aluminum. We then use the molar mass of aluminum given to us by the periodic table. And again, I'm going to choose to put moles on top and the grams on the denominator so that the grams of aluminum will cross cancel, getting rid of that unit, leaving me only with the unit that I want, moles of aluminum. Carrying out the simple multiplication and division, I generate a value of 0.371 moles of aluminum atoms. Now the number of atoms in 10.0 grams, aka 0.371 moles of aluminum, can be found by taking the number of moles of aluminum that I just generated, using Avogadro's number as a conversion factor, the number of atoms per mole. Okay, this is given to us by Avogadro. And I know that I'm going to put atoms on the numerator, moles of aluminum on the denominator, so that moles of aluminum can cancel out, leaving my final answer to be in atoms, having atoms for units. After carrying out the multiplication and division, I generate a final answer of 2.23 times 10 to the 23rd atoms. My reality check is that 1 mole of aluminum has a mass of 26.98 grams and contains 6.022 times 10 to the 23rd atoms. We know that because of Avogadro. Our sample is 10 grams, which is about, okay, roughly, again, this is just, roughing it here. We're not doing more calculations. It's about a third of the molar mass of aluminum, 26.98. Thus, the calculated value should be somewhere around 1/3 of 6 times 10 to the 23rd, Avogadro's number. And it is, right? We have 6 divided by 2, that's about 3. So it's not exactly 3, but it's around. And so what this does for me is it gives me confidence that my answer is on the correct scale.